Bismillahirrahmanirrahim. My name is Rumesa Malik. Today I am presenting my STATS final semester project. My topic is Global Earthquakes Statistical Analysis. I have chosen this topic, Global Earthquakes, because it is one of the most impactful natural disasters causing significant damage to life and infrastructure worldwide. By analyzing earthquake data, we can better understand their frequency, magnitude, and patterns. This statistical approach not only helps uncover key trends but also lays the foundation for improving earthquake preparedness and prediction methods so that we know how and what impact and what future impacts earthquake will have. This type of statistical analysis could be very practical. Initially, my dataset had 1137 rows and 43 columns, and after data cleaning and handling missing values, it remained the same as there were no null values in it. Firstly, I have calculated statistical analysis on ungrouped data. I have calculated central tendency measures like mean, which is 4.46, geometric mean, harmonic mean, etc., and dispersion measures like range, variance, standard deviation, etc. After grouping my dataset into frequency distribution table, I have categorized earthquakes into magnitude intervals. Basically, I have targeted the magnitude column. My main focus was the magnitude of the earthquakes and carrying out statistical analysis of group data on magnitude column. The highest frequency range of magnitude column of magnitudes was 5.5 to 6. Total 296 earthquakes occurred between this range. I have carried out central tendency measures and dispersion measures on this grouped data. I have also calculated skewness and quartile analysis and also interpreted their results. Grouped data provides insights into frequency distributions, while ungrouped data gives exact values. If we compare grouped and ungrouped statistical analysis of my topic, we can see that mean and median for ungrouped data is 4.46, which differs slightly from grouped data, which is 4.89. This basically tells us the earthquake concentration. Both analyses reflect the concentration of earthquakes in the moderate range of magnitude, which is 4 to 6. For conclusions, we have concluded earthquake concentration that earthquake magnitude of 4 to 6 are most concentrated in my dataset. There is slight positive skewness also, and for better understanding, you can see the complementary analysis in my project Python file, which is also attached in the second last slide of this PPT. For the future of such kind of project like global earthquakes, which cannot be predicted, I can say that by analyzing earthquake data, we can better understand the frequency, magnitude, and patterns. This statistical approach can only help uncover key trends, but also the foundation for improving earthquake preparedness and prediction methods. And if we get real-time data and we can dynamically update about dynamically give updates about this kind of statistical analysis, this type of project could be really practical.
These are the libraries we have used in the whole Python file. This is the loading of our earthquake CSV. This is the shape of our CSV, which is 1137 rows and 43 columns of total. This is just an illustration. df.describe, df.head for first 5 rows and all 43 columns. This is the method we have used to remove the null values or non-values in our dataset. This is the method we use to drop those rows which have too much null values. This is an earthquake location map, which basically tells us which places on map experienced earthquakes. This is another global earthquake distribution map on which if we hover on, we can see some specific details. of different colors that shows the depth. We also have a heat map. Then we have ungrouped data. Now we will carry out statistical analysis on the ungrouped data. For ungrouped data, for graphical representation, we have carried out a pie chart of all the countries, showing which one experiences most of the earthquakes. Then a simple bar chart between depth and frequency. A simple bar chart between depth and frequency. A multiple bar chart between magnitude and count. Then for measures of central tendency, we have arithmetic mean, which is 4.46, geometric mean, harmonic mean, median, mode, range, quartile, decile, percentile. For measures of dispersion, we have variance, standard deviation, quartile deviation, mean deviation, coefficient of range, coefficient of quartile deviation, coefficient of mean deviation, coefficient of variation, coefficient of standard deviation. For measure of distribution, we have measure of skewness using Carl-Pearson method, its interpretation, measure of skewness with Boyle's method and its interpretation, which says the distribution is positively skewed. Then we will group the data. We are basically working on the magnitude of the data. The main focus or the target column is the magnitude. So we have grouped the data. We have made the class intervals of the magnitude of the data, class boundaries of the magnitude, and then midpoints and frequencies and more than and less than cumulative frequencies. First, we will do the graphical representation of data for group data. So we have a histogram here between magnitude and frequency, a frequency polygon, an ogive, then we will carry out measures of center tendency like arithmetic mean. For group data, our arithmetic mean is 4.89. This is the geometric arithmetic mean, then geometric mean, log of midpoints and frequency of earthquake is multiplied in geometric mean, harmonic mean, and this is the table. Then median, mode, range. For measures of dispersion, we have carried out range, quartile, decile, percentile, variance, standard deviation, quartile deviation, mean deviation, coefficient of range, coefficient of quartile deviation, coefficient of mean deviation, coefficient of variation, coefficient of standard deviation. And for measure of distribution, we have carried out measure of skewness with Carl-Pearson method, and its interpretation says distribution is negatively skewed, and measure of skewness with Boyle's method, moments about mean, moments about origin, moments about arbitrary origin, moments ratios, and its interpretation. Skewness ratio, the distribution is positively skewed, and for kurtosis ratio, the distribution is plateautic negative.
Hope the PPT was informative. Thank you so much for your interest and time. If you have any questions, you can email me. Thank you.